Okay, continuing from the previous video, let's talk about how to implement the derivative term here. So to implement the derivative of the error, we can just simply take a derivative error, but how are we going to do it? Well, let's use a simple trick. So if we take the derivative of this error, which is derivative of this equation, and what is target? Target is a constant. So derivative of a constant is always 0, whatever that number is. And then derivative of negative sign is negative sign. And then derivative of the position is the velocity. So eventually my derivative of error is minus sign is coming from here, and then my velocity, which is my current velocity. So that's my d term. And my d out is the error times kd. I'm going to call this d error. I'm going to call my kd as derivative term. So kd is 1. And previously, I'm going to use just 1, 1. So kp is 1, kd is 1. And my overall pd out is p out plus d out. It's all plus because we have taken care of all the signs in our calculation here. So that's my PD out, and that's my reference here. Let's just run this. I'm going to reset this just to make sure, and Control Enter. The car was kind of slowing down, but it again passed the traffic light. And then it's kind of coming back, and eventually it stopped. So there's no more oscillation. Look at this beautiful graph here. The velocity was increasing, and then as it reaches to the target point, it kind of decreases, but it's kind of overshooting it. Now let's look at the position graph here. It started from -7, which is here, and then it reaches to the traffic light, but still it didn't really sufficiently decrease its velocity, so it overshoot. It passed the traffic light by 1 meter, and then it kind of went back. And then that's our input acceleration. So how can we fix this overshoot? Well, simply, I'm going to change this kd to number 2. So it's all proportional gain. So it's just like random constant that you need to adjust to finally literally adjust the behavior of your entire system. So I'm going to make it 2 as kd. So I'm going to run this again. Before I do that, let's not forget to reset the car and run. So it's kind of slowing down a lot better than the previous one, and then I think it eventually stopped at 0 position. Like that. So eventually we stopped the car at the 0 location. But just to make it more like, fun example, say this is kind of like half of the car is passed. So let me make the target position as, I don't know, -0.5 with this same KD and KP. So by the graph is right, but just by the simulation is the half of the car has passed the traffic light. So let's just make the target value as -0.5. Oh, I forgot to reset the car, so let me stop that. Yeah, it's kind of trivial because the car didn't really move a lot, and it's 0.5 meters. So let me reset the car and run this again. It stops there. Still, I think -0.5 wasn't sufficient as our target, but you know what I mean. So by adjusting this target now, you can control the car. If you're curious, I recommend that you play with this target value and KP and KD on your side, because this lab is prepared for this purpose. Otherwise, I'll see you in the next video.